Welcome back to Speller Tutorial Services. In today's video, we're going to use the quadratic formula to solve a quadratic equation that has complex or imaginary roots. Alright, let's begin by identifying the a, b, and c that are necessary for the quadratic equation or the quadratic formula. Here, the coefficient in front of the x squared term, and that's going to give us a. In this case, that's 5. B is going to be the coefficient of the x term, which is 2. And c is going to be the value of 3. The formula for the quadratic formula is negative b plus or minus b squared minus 4ac, and that whole quantity divided by the expression 2a. Now let's make our substitutions. B here has the value of 2. B squared is 2 times 2, which gives us 4, minus 4 times a, which is 5, times c, which is 3. And that's going to be divided by 2 times a, and in this case a is 5. Now we'll continue by evaluating what's underneath the radical here. So I have 4 times 5 is 20, and 20 times 3 is 60. And then the denominator here is 2 times 5, or just 10. We'll continue to evaluate what's underneath the radical. I have 4 minus 60, which gives me a negative 56. All of this here divided by 10. We'll continue up here at the top. We're going to take that negative 56, and I'm going to do the prime factorization. I know that 8 times 7 gives me 56. To get 8, that's 4 times 2. And to get 2, that's 2 times 2. So now I've broken that 56 down into all of its prime factors. And I have to remember it's a negative, so I know that I'm going to also have a negative 1 here. So what I end up with is negative 2 plus or minus 2 times 2 times 2 times 7 times negative 1. And where all of that is divided by 10. Again, I know with a square root, I'm looking for pairs. Alright, let me rewrite that. Negative 2 plus or minus. And with the square root, I'm looking for pairs. Here I have a pair of 2's, so that means that 2 escapes. I also have a negative 1, which comes out as I. And then the leftovers are 2 times 7, or just 14. And then my denominator here is 10. I see that my negative 2, my 2, and the 10 in my denominator all share a GCF of 2. So that means I can divide each one of those numbers by 2. Well, negative 2 divided by 2 gives me negative 1. 2 divided by 2 gives me a positive 1, which I don't need to write because I'm multiplying. And then in my denominator, 10 divided by 2 gives me 5. So my complex root for this particular quadratic equation is the quantity negative 1 plus or minus I root 14, where all of that is divided by 5. Alright, that sums it up for this particular video. Please friend us on Facebook and also subscribe to our YouTube channel, both found under the same name. And thank you again for watching.